You know the exact feeling of opening a car door on a 100-degree July afternoon. It is a physical wall of heat. You experience a similar shock opening your summer power bill after the air conditioning has been running for weeks. Standard glass surfaces allow solar energy to pass through unhindered, effectively magnifying the heat before it reaches the interior. Inside a vehicle, this magnified sunlight bakes the cabin. It actively degrades leather upholstery, pushes interior temperature to dangerous extremes, and exposes passengers to direct radiation. The exact same thermal trap happens in our homes and offices. Ambient sunlight bleaches luxury hardwood floors and forces HVAC systems into a continuous, expensive battle against rising temperatures. For decades, the solutions were frustrating compromises. People hung heavy blackout curtains that ruined their natural view, or applied cheap dyed window tints that eventually bubbled, peeled, and turned purple in the sun. The modern engineering challenge is highly specific. We need to filter out the destructive heat and radiation while explicitly allowing the visible light to pass through. To solve this, we have to look at the physics of sunlight. The light hitting your window is not a single beam. It is a combination of 3 distinct energy waves arriving at the exact same time. This 3D cross-section breaks a single sunlight ray into its components. First, visible light passes through safely. Next, ultraviolet rays penetrate, causing severe fading on furniture. Finally, infrared heat pushes thermal energy inside, creating rapid, uncomfortable temperature spikes. Traditional dark tints fail because they attempt to block all 3 waves equally, using cheap dyes to absorb solar energy directly into the glass. It acts like a black t-shirt on a hot day. The heat still radiates heavily into the cabin. A true thermal solution requires a material engineered to physically recognize and repel the destructive UV and IR waves without blocking the visible light. Modern C2 nanocarbon and ceramic films rely on a multi-layered construction of advanced materials, performing entirely differently than chemical dyes used in basic manufacturing. Microscopically, millions of uniform nano-ceramic particles form a dense lattice shield. When UV radiation hits, the film blocks 99.9%, bouncing it away. It simultaneously repels massive amounts of IR heat. By selectively targeting these frequencies, safe visible light simply slips through the gaps. This selective targeting proves that you no longer need a pitch-black limo-style tint to drop the temperature. A nearly clear ceramic film can reject significantly more heat than the darkest traditional dyes. Nanotechnology alters the physical behavior of the glass, upgrading it from an environmental vulnerability into a highly efficient thermal shield. For drivers, this translates to immediate, measurable protection. Sensitive electronic dashboard displays avoid overheating. High-end leather interiors resist cracking, and the air conditioning system draws far less power to cool the cabin. As this infographic shows, there is an additional technical advantage to these specific materials. Because carbon and ceramic films are completely non-metallic, they guarantee zero interference with your smartphone, GPS, or tollway transponder. This identical physics directly benefits real estate. By rejecting solar heat gain before it penetrates the building, property owners drastically lower residential and commercial HVAC utility costs. While the heat rejection mechanics are the same, residential and automotive glass expand and absorb energy differently. Professional installers use distinct films engineered specifically to handle the flat stress of buildings versus the curved, tempered glass of cars. These films function as high-performance components for both vehicles and buildings, offering a layer of utility that extends past simple privacy or aesthetics. By applying advanced material science directly to our windows, we control exactly how our environments interact with the sun. We reduce energy consumption, preserve our investments, and ensure daily comfort without ever losing the view.